Dear students, today we are going to discuss about homogenization. Actually, first let us see what is this. Homogenization is a process to find pair of lines joining origin with point of intersection of a curve and a line. See here, you know that, suppose let us say this is a second degree curve. You know that this is, let us see, and this is a straight line. Equation number 2, let us see. And we know well most of the second degree curves we are getting equation ax square plus bx square plus 2hxy plus 2gx plus 2fy plus c equal to 0. And line equation, let us take lx plus my plus n equals to 0. Now you see equation number 2. What we are saying now, suppose if this curve and the line both are intersecting at 2 points A and B, and many times we need to find out the pair of lines joining origin with these points of intersection. Let us say this is OA and OB. We need to find out these two. So you may have an idea, sir, we will solve this line with this curve and we will find out A and B and then we will find. But of course, this is a way. Everywhere there is a raw way. But if you go with the from basic way, there is no need of science. So now here we are going to find out a method called homogenization, where we will find the pair of lines OA OB without solving. See how. We know that basically OA OB pair of lines, also a pair of lines which will be in the form of second degree, but it doesn't contain the first degree terms or constant. It will have only in the form of ax square plus 2hxy plus by square. So from this, indirectly what we need, we have to find out a homogeneous equation, that is ax square plus 2hxy plus by square, which satisfied by origin as well as these two. For this, what we are doing here, see. First I'll explain the procedure and then I'll explain how it works. Now see, from this line equation I am making lx plus my equal to minus n equal to 1. Means what I have done is the same equation 2 that I have expressed in a different form. I have transposed minus n to other side and then I have divided. So you may have doubts, sir, what does it make difference? Yes, lot difference, because 1 मालिक एक है, 0 हीरो है, कई बार बोला है, मालिक तो हमको हेल्प करता ही है. चलिए, तो एज पर आवर बिलीफ मालिक की हेल्प करेगा नहीं करेगा भगवान, बट यहां पे तो हेल्प करेगा ही भाई. A1 हेल्प करेगा. कैसे देखिए, सी नाउ homogenizing, you know the meaning of homogenization. Homogenized equation means the equation containing all the terms of same degree. So here, as it is a second degree, we need all this first degree and constant also we need to change now into second degree. That is what we call homogenization. Means actually it is not homogenized equation, it is non-homogeneous equation. We are converting it to homogeneous. Okay. Now let us see. Homogenizing 1 with the help of 2. See what I am doing. See the equation number 1, which I want to convert into homogenized. Ax square, which is already second degree, we need not change anything. 2hxy, again it is a second degree where you need not change anything. And plus by square, which is also again second degree. We need not change anything. But now the time comes 2gx, which is of first degree. Okay, and what we need to change is it into second degree. So what I am going to do is this 2gx, which is the first degree, I am going to convert into second degree. For that I am multiplying with 1, again 2fy, it is a first degree, again I am multiplying with 1, the c constant, which is 0 degree, but that I am going to multiply with 1 square, is equals to 0. 2gx into 1, 2gx only, 2fy into 1, 2fy only, c into 1 square is 1 only. You may have a doubt, or you may wonder that, sir, what does it make? When you multiply, 1 doesn't make any difference. Yes, this is what Malik ek humko help kar raha hai, dekhiye. So now what I am going to do is, in the place of 1 I am going to substitute this particular expression, which is equivalent of straight line in the form of equivalent to 1. So now I am substituting here. See, ax square plus 2hxy plus by square plus 2gx into, in the place of 1 we are having lx plus my by minus n, plus similarly here also 2fy into multiplied by lx plus my by minus n. So here there is no place, I am writing plus c into, in the place of 1 square, where we are getting 1 plus x plus whole square equals to 0. Oh, I am sorry. See here, now I think it is visible. Lx plus my by minus n whole square equals to 0. Now you can observe, if you simplify this equation, the above equation, here x square, xy, y square, and here also x into x, x square and xy, only second degree, y into x, yx, and also y square, it is also second degree only. And you know well, of course, lx plus my, when you make it whole square, it always gives you some square term, x square term, y square term and xy term. Means on the whole you can observe that the entire expression now, entire the equation contains only x square, xy and y square terms. Hence it is a homogenized second degree equation. So on simplification, the same thing I am writing. We need not write everything in clear, that when the numbers are given you can simplify. So on simplification, it comes into the form some capital A x square, because actually what happens here, the x square you are getting 3 times, once here, once again here, 2gx lx by minus n, and again once again you are getting here. So that's why some x square coefficient you will get, that I am representing with capital A, so that we will not mistake with that. And 2 capital H x y, similarly all xy terms I have taken together, by square, again the same story, I have taken all the y square coefficients together, which is very clearly what? Second degree equation, which is in non-homogeneous form, as we have discussed in the initial pair of straight lines. Any equation in the form of ax square plus 2hxy plus by square homogeneous form, it will represent a pair of lines which is passing through origin. So clearly 0, 0 it is satisfying, number 1 point. Number 2, you please observe that lx plus my by minus n, it is satisfied by both a as well as b. Am I right or not? Yes. Similarly, the a and b both satisfy 2gx plus ax square plus 2hxy plus by square plus 2gx plus 2fy plus c, that is which first equation, and this is a equation formed by the both. So this equation will be satisfied because lx plus my minus n also satisfied by ab, and this entire equation also satisfied by a and b. So what finally we can conclude? We can conclude that it is a pair of lines which is satisfied by capital A and capital B points also. Okay, so that's why here very clear, pair of lines satisfying origin and satisfying AB, so therefore it will represent OA and OB pair of lines equation. So it represents, which represents pair of lines. This is what we call homogenization, which helps us to find out the pair of lines joining origin with the point of intersection of a curve and a line. Please note it. We will go with the problems on this. Okay. Thank you.